Thank you, Brian. So you've seen a little bit about capture, now how we're going to move the CO2. And Sai is going to talk about what you do once you get it to the place where you're going to store it. Mostly what we mean by storage is putting it deep underground.
All right. Thank you, Bob. Since Raj captured the CO2 and transport the CO2 by utilizing Balian's pipeline to me, then what am I going to do for this large volume of the CO2 in the field? So previously, we utilized the CO2 for the UR to enhance the oil recovery. And some other methods to utilize CO2, probably we can convert the CO2 to some other products like protein, even fuels. And in chemistry, we can utilize the CO2 as a extraction agent for the critical mineral extraction from the mining side, whatever, and also this supercritical CO2 can be utilized as a cooling agent for the food, this kind of industry, okay? But we still have a large amount of CO2 existing after the capture and transportation, okay? And over the last 20 years, like Bob mentioned, we inject CO2 directly to the subsurface, deep saline aquifers for sequestration, but that's the traditional CCUS, okay? Another topic recently right now, DOE is trying to revoke it, is to study the mineralization process. In New Mexico, even the west side of the United States, we have a lot of resource. Okay, let's go ahead. We have a lot of resource for the basaltic rocks on surface, even subsurface, okay? Around over decades in Iceland, they already studied the carbon fix project right there. They started inject the CO2 to the subsurface basaltic formations, trying to store the CO2 in the basaltic rocks, okay? But in US, there's a little bit delay on that portion. As far as I know, we have several projects ongoing right now. The first one is the Washington State, Wallula Basalt. They have projects ongoing. And early this year, Wyoming got another project, the Hero Basalts. They are trying to study the Wallula Basalts in the Washington State and see the potential right there, okay? In New Mexico, we do have those kind of similar results on the surface and subsurface, okay? So my topic right here is trying to see what's the potential, what's the resource for this mineralization in New Mexico and the surrounding areas, okay? So let's back to the fundamental research right here. What is the carbon mineralization, okay? Basically, we just inject CO2 to the basaltic rocks and let them react to generate the carbonate minerals, okay? So there are several categories for the mineralization process. The in situ mineralization, which means we utilize the similar ideas for the traditional deep saline aquifer CO2 storage. We purely inject CO2 assisting with water into the subsurface basaltic formations and let the CO2 react with the ultramafic rocks and generate the carbonate minerals and permanently store the CO2 on the subsurface, okay? Another category is the ex situ mineralization process. This is, we utilize the alkaline feedstocks and react with the concentrated CO2 under the high temperature conditions in the reactor and generate the carbonates concretes, okay? So there are also some other categories like the surfacial one, but my project right now is only focused on the top two, the in situ and ex situ mineralization process. So I will skip the surfacial portion for now, okay? So my projects, I got this one like last year, And my team is working on this topic. The project objective is trying to identify and access the state-wise resource for the potential CO2 storage through the mineralization process, including the subsurface basaltic formations, near surface basaltic formation, and surface basaltic rocks, and see if there is a potential for the mineralization. Okay, not only the basaltic formations, we also trying to identify the relevant stratigraphic units. Let's see the cap rocks, which can cover us to protect us for the potential CO2 leakage. Okay, and after that, we also we did some field trips and for the rock samplings and mapping. Right here, I really want to thank Bureau of Geology, their support for the field works and mapping, and even Sherry Kelly for the geothermal portion to support the water supplies on this project. Okay, and let's back to the objectives. Okay, so we did a lot of work on the field trip and get the rock samples from the field, trying to characterize them and see their reaction rate with the CO2 and water, and assisting with the water. Okay, and trying to have a fair idea where is the best location for us to do this kind of mineralization, and how we're gonna upscale this idea to the local communities. Okay, so here the map on the right side shows the main basaltic field in New Mexico. Okay, we do have the Taos Plateau area, Raton area, and even Zuni Bandera, Mount Taylor. They are very big. Okay, so those kind of resource we can consider to utilize as a mineralization site. And my team did a rough calculation. So if we utilize all those basaltic rocks for the mineralization, over 3.4 gigatons of CO2 can be stored through this mineralization process. Okay. This is the near surface basaltic fields. Okay, we also have some other potential sites for the subsurface basaltic formations like Albuquerque Basin. Up to 6,000 feet, we found several interbedding layers for the basaltic ultramafic rocks right there. And another field is the damming area, the southwest of New Mexico State. In that area, we have a fair idea and that the subsurface, we do have a formation right there, but the challenge right now is data is pretty challenged to get. You know, those kind of areas is far away from oil and gas production, so not a lot of well penetrated through these formations. So data is an issue right now. But my team still working on those data collection. Hopefully, we can get a positive feedback outcomes from those from this project. Okay, and besides that, I would to add a little bit on these basaltic rocks, especially for the ultramafic rocks. You know, this year we got another project on the geological hydrogen production. You know, this is also from the ultramafic rocks. Okay, the olivine. Okay, so we are trying to study the potential reaction and try to accelerate this reaction rate and produce more wet hydrogen, which is the geological hydrogen production from the ultramafic rocks. Okay, and another thing is I want to mention is we are trying to explore the potential to combine the hydrogen generation through these ultramafic rocks with the carbon mineralization for dual benefits. Okay, yeah, that's that's all for my topic. I'm open for any questions. Thank you.
So in carbon storage, basalts are really interesting because typically if you put the CO2 into the ground, the reactions are much slower and take decades or hundreds of years to get to a large amount of mineralization. But you're talking about days, weeks, and months for for